Good morning. My name is Hector Salcedo. I am the project manager for the I-15 Franklin Interchange Design Project. At this time, I would like to introduce our team.
My name is Jeffrey Sue. I'm the other project manager for this group.
Kevin Sato, Traffic and Transportation.
My name is Bassel McCarron, Advanced Planning Study and Environmental Planning Study.
My name is Felipe Cifuentes, and I'm part of the design team.
My name is Jeremy Paulson, and I'm part of the geometric design team. My name is Teddy Rupalikatsagit, I'm part of the design team.
My name is Fabian Allen. I'm the design team lead.
My name is Anthony Vu, I'm traffic lead.
My name is Dylan Sanchez, and I'm part of traffic.
So now to get started, quick overview of what we will be going over through today. We'll be going over our background, our purpose and need, scope of work, geometric design, intersection control evaluation, traffic analysis, environmental studies, our advanced planning studies, cost estimates, and finally our recommended alternative and construction stage report. So real quick to begin, I'd like to introduce our partners for this project, which included Caltrans, us, and the city of Lake Elsinore. Our project is located in the city of Lake Elsinore, which resides in the county of Riverside. There were two project teams for this specific project location. One, which is at Railroad Canyon Road, and us, which focus on the existing Franklin Street overcrossing bridge. Our project study area expanded from Main Street, which is just north of Franklin Street, and it went all the way down to Railroad Canyon Road, which is just south of Franklin Street. We will focus mainly on the Franklin Bridge overcrossing for our project. Currently, it's an overcrossing bridge. It has some residential units to the east, and then some commercial and residential units to the west. So why do we need a new interchange at Franklin Street? Well, in Riverside County, there has been a high growth in population. In the last 15 years, there's been about more than 30% increase in population, making it the highest county increase in population in California. The city of Lake Elsinore has experienced the same kind of growth. Currently, there's about 56,000 people in the city of Lake Elsinore, and it is projected to have more than 100,000 by 2040. According to its general plan, at our location, there will be high residential and commercial units being implemented, as well as some industrial units. According to the circulation plan, the city has a plan to build out new local streets and roads, including one that is just north of the existing Franklin Street, which is an overcrossing bridge or some sort of interchange. So what happens if we don't build an interchange at Franklin Street? Well, the projected 20 and 40 traffic will go to a level of service of E and F. And then if we don't build it, Railroad Canyon will experience Fs, even if they modify or build a new interchange. They need Franklin Street to have a new interchange so their levels of service can go up. And now I'll be handing it off to Jeff for the purpose of this.
Thank you, Hector. Our purpose and needs for this project directly address the issue of future growth of the city and the future traffic breakdowns. The purpose of this project is to provide safe and efficient local and freeway accessibility for the future of the city, and our needs are to accommodate city development and city growth for local circulation and access to the I-15, to improve existing and future congestion at Railroad Canyon Road and throughout the entire city, and to provide safe access for bicyclists and pedestrians. The scope of work and deliverables for this project included a project study report, geometric approval drawings, intersection control evaluation, traffic simulation and modeling, preliminary environmental analysis report, advanced planning study, construction staging, cost estimates and benefit analysis, and a weighted decision matrix to decide our recommendations. Now I'll be handing it over to Felipe to talk about geometric analysis.
Thank you, Jeff. I'll begin discussion on the geometric analysis. We discussed at the very beginning many different alternatives. Of the following, we decided to eliminate the split diamond with braids, slip ramps, hook ramps, and the full cloverleaf due to design and traffic reasons. There were four alternatives which are further discussed, which were the tie diamond. We discussed a variation of the spread diamond, a variation of the cloverleaf, and the single point interchange. There were two design exceptions for all four of these alternatives. The first is the interchange spacing between the newly designed Elsinore Hills Bridge and the Main Street interchange to the north. This spacing is 0.78 miles, which is less than the 1 mile required by the Caltrans Highway Design Manual. This is due to the fact that the spacing between Main Street in the north and Railroad Canyon in the south is 1.78 miles. Thus, it is impossible to create an interchange in between them that does not have a design exception. The second design exception is the intersection spacing between Canyon Estates Drive and the northbound I-15 off and on ramps. This is due to the fact that there is a landfill that is east of the I-15 that gives us design constraints. The following is the auto turn analysis that was done. It was done for every single alternative using the Caltrans STAA lawn truck, and this is just one of the critical turning movements that was shown. Now to move on to our alternatives. The first alternative is the tight diamond interchange. This is a very common alternative, and it's typically designed in intersections where right-of-way is concerned. There are many advantages to the tight diamond. One, which is its low cost, especially because little right-of-way is needed for this design. Second is its ease of construction. And lastly, it has an increased interchange spacing between our ramps and the north and the Main Street ramps on the north, and our ramps and the ramps on Railroad Canyon. There are also some disadvantages to this design. The first drawback is its lack of adaptability for future expansion. Second, it's its intersection spacing, especially between one ramp intersection to another ramp intersection. Lastly, because of the shorter ramps, it leads to steeper vertical grades than the other alternatives. Discussing on our next alternative will be Jeremy.
Thank you, Felipe. The next alternative that we considered was the split diamond interchange. Originally, the split diamond started out as a spread diamond because the location of the project had limited constraints, and the spread diamond offered a lot of advantages. However, during the geometric design process, it was converted into a split diamond. This happened because there wasn't enough space between the ramps from the interchange to the north at Main and the U interchange to allow for weaving. So the solution was to convert those ramps between the two interchanges into collector distributor roads, thus making a split diamond. Since the interchange is new and its life will exceed the 20-year traffic study, having an adaptable design for the future is ideal. One of the main advantages of this alternative is that it has space to accommodate the future loop ramps to accommodate the growth, as you can see in the green. Another advantage is that the collector distributor roads help to keep traffic away from the local streets, which reduces its impact on local circulation. In addition, the spacing between the ramp terminals gives greater sight distance and allows for more left turn storage capacity. The main disadvantage is that it's large, so it's going to have more right-of-way impact and a greater environmental impact. Another disadvantage is that the collector roads may be confusing to drivers, and especially drivers on the freeway trying to exit it. They may miss the street they're trying to get off on, and there won't be exit ramps later on. And lastly, because of its large size, additional roadway and earthwork, it has a higher cost than the other alternatives. Next, I'll be passing it on to Teddy.
Thank you, Jeremy. Alternative 3 of this project is a partial clover interchange. So with this partial clover interchange, we decided to put the ramps on one side of the bridge, making it pedestrian friendly. So as you can see by the green line there, we can put the sidewalk on just one side of the bridge so pedestrians don't have to cross over those ramps there. Another advantage is that there's adequate ramp spacing between the design ramps in blue and the Main Street ramps shown in black to the north. And these ramps also provide a safe weaving distance because they are relatively long, and the transition onto the highway is relatively long as well. There's also future adaptability available for this interchange. As you can see here in green, if we need to, we can always add ramps on the other side of the bridge as well. Unfortunately, it does have its disadvantages as well. While the sidewalk being on one side is great, it is only on one side. So people who may be coming from the eastern side of Canyon Estates Drive or Franklin Street do have to cross the street to get to the other side of the bridge first. There are also bicycle vehicle conflicts. Bicycles can't be moved to one side of the road the same way pedestrians can. They do have to follow the flow of traffic. So they do have to cross over those ramp terminals there, which could cause some conflicts with oncoming traffic. Lastly is driver expectation. Drivers can't get off the freeway and get right back on it the same way they can for an interchange such as the tight diamond. Instead, they'll have to go back up to that roundabout to the north and turn around and come back down the bridge before they can get back on the highway. Now for alternative 4, I'll hand it over to Fabian.
Thank you, Tate. Alternative 4 is the single point urban interchange, or SPUI. Now, a SPUI is not normally considered for a brand new interchange because it's complex and it's not commonly seen in the US or California. However, the Highway Design Manual does require that all viable alternatives be considered during the planning process. The main advantage of a SPUI is its ability to combine a high capacity or to have a high capacity of traffic with only one intersection, shown in the green. This allows for right turn movements to be completely free and left turn movements and through movements to be signalized. And because of this, it has a very short delay time. It actually was shown by our traffic team to have the shortest delay time of any alternative considered. Another advantage of this single point urban interchange is the large intersection spacing it has. It's actually the only alternative that does not have the design exception between the interchange or the intersection at the north and the ramps to the south of it. The SPUI does have some disadvantages. It's not adaptable like the spread diamond. It cannot be modified to increase its capacity in the future. If it breaks down, a whole new interchange will have to be constructed. Another disadvantage is its high cost. Each ramp will have to have its own bridge structure to support it, thus increasing the cost. Another disadvantage is that it's very difficult for pedestrians and bicyclists to navigate. A pedestrian wanting to go from the south side of the bridge here up to the north has to go through 4 different crosswalks as shown by the red dots. And lastly, it does not meet driver expectation. Again, the SPUI is not commonly seen in our area, and drivers may have difficulty adapting to its operation. For the alternative selected, I will be handing it to Anthony to discuss intersection control evaluation.
So because of the new geometric layout and several new intersections were created, we will be determining the traffic controls for these intersections using Policy Directive 13-02, or ICE. So before we get to the results, I will go through a short example to show our ICE methodology. ICE is a 2-step process. The first step is assessment and screening of different control types. This table below summarizes feasible control options for each intersections. These control types will continue on to the next step, engineering analysis. In the engineering analysis, we performed a signal warrant study for each of the intersections shown here. So the results of the study show that all the intersections satisfy warrant 3. And with that and some engineering judgment, we decided to eliminate stop control from further analysis. So let's compare the remaining intersections now. For this example, we'll be looking at intersection 3 at Elsinore Hills and Canyon Estates. The table here shows the comparison between the roundabout and the signal control. As you can see, the roundabout outperforms the signal control by a large margin. So with this cost and safety in mind, we decided to proceed with the roundabout for this intersection. We then would proceed on to the next intersection and the one after that until we get our final results. So the results for the SPUI showed that all the intersections will be signalized except for the roundabout at Canyon Estates and Elsinore Hills. This will apply to also the tight diamond and the partial clover. The split diamond, however, is signalized control at all intersections. So once we finish with all the evaluation, we can move on to the traffic analysis.
Thank you, Anthony. After completing ICE, we proceeded with our traffic analysis using SYNCHRO. The goal of our study was to determine the levels of service for each alternative to determine their capacity and performance. This process involved modeling each alternative according to their horizontal alignment and inputting projected peak AM and PM 2040 turning movements as provided by Caltrans. Also, the appropriate control types were assigned to each intersection as per the ICE analysis. The generated report then provided us with the intersection delay and respective level of service. So for our first alternative, the tight diamond achieved an average level of service peak Despite the spacing between interchange intersections, the signalized control allows for efficient traffic movement. For the split diamond, it also achieved an average level service B despite the 2 additional intersections at Main Street. However, the southbound off-ramp at Elsinore Hills did experience level service C, as it must handle traffic from Main Street entering the I-15 and traffic from the I-15 exiting Elsinore Hills. Next, the partial clover also averaged a level of service B. This is due to its adequate intersection spacing and optimized signal control. For our final alternative, the single point urban interchange also experienced an average level of service B. The use of one intersection to handle all left and through traffic movements in conjunction with 3 rights results in shorter delays. So as you have seen, all four of our alternatives experienced levels of service C or better, but this was not unexpected as our project involves a completely new interchange. With that said, we'll move on to the environmental studies, which will be discussed by Dassen.
Thank you, Dylan. For the environmental planning study, we primarily focused on the preliminary environmental analysis report. This report provided us with many environmental considerations to look into, and among them we found 0 to minimal impact. For example, for biological habitat and hazardous materials, we found very little impact. However, for the hydrology and floodplain, we did find a 100-year floodplain bordering the I-15, but with proper mitigation such as storm drains and other types of drainage features, we will have very little impact and environmental clearance per this preliminary environmental report. That being said, for the policies enact NEPA and CEQA, we will have a finding of no significant impact for NEPA and a negative declaration for CEQA. Okay, for the advanced planning study, we received our structure was feasible and come up with appropriate controls for the specific locations, such as vertical clearances. For the partial clover, there will be a cast-in-place pre-stressed concrete box girder structure with a double-span continuous bridge with a total length of 320 feet and a bridge depth of 7 feet. The vertical clearance will be 18 feet and 5 inches due to the ramps going under the bridge, and the false work for this project will be 3 feet and 5 inches. The other 3 alternatives, they have the same advanced planning study due to their geometric features. That being said, for an example of single point urban interchange, we'll have a cast-in-place pre-stressed concrete box girder and a double-span continuous bridge as well, with a bridge depth of 5 feet and a total span length of 230 feet. The vertical clearance will be 21 feet and 8 inches, and again, the false work for this project will be 3 feet and 5 inches. Here's Jeff with the cost estimate.
Thank you, Bassam. So we performed cost estimates for each of the alternatives. We included the cost of roadway, bridge, right-of-way, design, construction and administration, and a 25% contingency. The SPUI was the most expensive at $115 million. In addition to cost estimates, we performed benefit analysis for each of our alternatives. We calculated the benefits of constructing Franklin Street interchange compared to not constructing the interchange. We included benefits of accessibility benefit, total vehicle delay saved, total vehicle stop saved, fuel use reduced, and CO2 emissions reduced. For accessibility benefit, we started at a point in the future residential area and measured the travel time to access the I-15 from this point to at Railroad Canyon Road interchange because Franklin's not built. Then we measured the travel time from the same point to access the I-15 if Franklin Street interchange was built. The difference between these 2 travel times is our accessibility benefit. This graph shows the total delays, total stops, fuel used, and CO2 emissions for our entire study area. The red bar represents these values if Franklin Street interchange was not constructed, and the green bar represents these values if Franklin Street interchange was constructed. By comparing these 2 values, we can see that building Franklin Street interchange significantly improves our study area by reducing these values anywhere from 15% to 23%. Here's a graph showing the annual benefits each year from the year 2020 to year 2040 for each of our alternatives. And here's the total benefit for each of our alternatives. The SPUI is the highest at $120 million. So with the cost and the benefits, we were able to create a calculated benefit to cost ratio. The tie diamond had the highest at 1.38. In addition to the benefit cost ratio, to determine our recommended alternatives, we created and analyzed the weighted decision matrix. The categories we considered listed in order of importance are local circulation, benefit, adaptability, pedestrian bike friendly, cost, freeway operations, environmental impact, right-of-way impact, and ease of construction. We weighted each category, assigned a score using engineering judgment, and calculated a total score for each category, or for each alternative. Here's the table summarizing the total scores for each of our alternatives. The partial clover scored the highest, so we continued with the partial clover alternative as our recommended one. And now I'll be handing it over to Kevin to discuss our construction stage.
Thank you, Jeff. So the following is the construction staging for the partial clover. So in stage 1, we're going to start by removing Brenda Drive. Then we will proceed to do the excavation work along Canyon Stage Drive. We will use some of this earthwork when we close down the existing canyon estates in order to create a new road and a new intersection. Simultaneously, we're going to be closing down a couple of dirt roads that exist on the southwest side of our project area. This will give us enough space to be able to build the new Franklin Street. Additionally, in stage 1, we're going to be constructing the columns for the bridge. In stage 2, we're going to be removing Avenue 6. This will give us enough space in order to do the earthwork for the bridge approaches on either side of the I-15. In addition, this is when the abutments will be put into place. In stage 3, this is when we're going to do the construction for the Elsinore Hills Bridge. In addition, we're going to also be doing the earthwork for the northbound and southbound ramps. In stage 4, that's when we're going to start the paving along Elsinore Hills and also on the ramps. At the same time, we can also be building the ramp on the roundabout on Canyon Stage Drive, in addition to the paving along Canyon Stage Drive. And this will be the completed construction of what it looks like. Now I'll be handing it back over to Hector.
So now for our recommended alternative, we provided a video simulation of how it would operate. Here, starting on the west side of the ramps, you can see the traffic moving eastbound. And here you can also see our adequate spacing of each ramp. We're approaching the off-ramp on the north-hand side, and now we'll be going on to near the roundabout. Here you can clearly see the grade operation of the roundabout as tested and provided by traffic analysis. With that said, our preferred alternative, the partial clover, improves the local access to the I-15, it reduces the congestion at Railroad Canyon Rail, and will be adaptable, safe, and cost-effective alternative forward. At this time, I'd like to take time and acknowledge all the people who helped us on this project, especially to our advisors, Zhidong Jia, John Bumps, and David. We will take questions at this time.
Okay, great job. I think every year the teams seem to be getting better and better, and the technical analysis is just, I think we're blown away. So I had an environmental question. The Canyon Estates Drive, that appears like it will have a huge impact on existing development as far as right-of-way acquisition. Can you talk about, or if that alternative, partial cloverleaf and right-of-way involved, if that were to actually take place, do you think there would be community support, business support? Do you have, would you expect any opposition to taking the businesses or homes to realign roads and that sort of thing?
I can answer that for you. The Canyon Estates Road that you're referring to, yes, it is a large road, and it will have a large impact. And the reason it's there is because it's also included in the city's general plan. So there will be a road extended that way. So I think community support shouldn't be an issue as far as Lake Elsinore communicating that with their citizens. And for the right-of-way costs, I think that's going to be part of their improvement anyway. It shouldn't have a huge effect on our interchange. It shouldn't be difficult to implement for us.
I'd also like to add to that. Currently, in current conditions, that whole entire area is undeveloped. They're just completely dirt roads. And additionally, in the general plan, in the future, for future development, it's planned to have a commercial area. So having that Canyon Estates Road will be beneficial to have access to that commercial area.
Okay, so when we add a new interchange on the interstate system, we require federal access or a new connection. Do you think, based on your analysis, you have enough data that federal government will approve interchange at this location?
I believe so. Again, the main purpose of our interchange is the city needs an interchange. I believe at the start of the project, we mentioned, the project was pushed by the city to Caltrans because it was in the area. As far as it being approved by FHWA, I think it'll probably take a lot of time for it to get approved, just because you have to get everyone on the same page. But as we've shown, I mean, the benefits are there for the future, and I think in the long run it will only benefit both the city and Caltrans. So I don't see why FHWA would support it.
Great job again. This is the first time we sit through two presentations back to back. And I kind of expected much of the same, but I was really impressed to see there was quite a difference between the two presentations. They were both really good. There were only a couple of slides that were similar. Overall, there was some really great information in both of them. And it was also nice to see a roundabout that did not break down. I do have a question regarding the weighted score. I'm not too familiar with it, but I noticed you're using numbers from 1 to 9, and you're not repeating any numbers, like you don't have 2 and 2, for example. Is that on purpose? Because somehow it may give unfair advantage to one area than another if you're spreading the difference. 1 is 1 and 1 is 9. Can someone answer that?
Yeah, we did think about that when we were doing our analysis, but according to this methodology, the research that we did, we had to rank it from 1 to 9, and then our rate had to be 91.
So
Using this method again.
So this is the criteria of
Yes.
this analysis. Excellent. Great job.
All right. Excellent. Good presentation. I like all the details in there as well, and roundabout was approved. So good. This kind of ties into the environmental, the open space, and the general plan. And once construction is complete, one of our customers in the end is the maintenance division. I did see the open space. Any details into the landscaping and the maintenance effects afterwards? I know in the last simulation there was kind of just open space.
In terms of maintenance and operation, we didn't really look into that. Our scope of work, for our time frame, just focused on, designing the interchange, and then, or thinking, in the future, Caltrans will have the maintenance and operation of or the city of the local streets.
Okay. Going back to the staging, I know you went to the staging. Did you come up with a time frame, the total construction time completion? That's a one-part question. The second part question on that is combining both projects here in the sequencing of it, since it's two intersections together. And this is probably for both teams here, because in the real life situation, we do have corridors that are going on. I'm sure you've seen that in previous years, like 215 and 91, Riverside, Pomona, and you'll see that here in the near future as well. But there are several interchanges that are being constructed out there in sequence and such. And in coordination with the level of service, I saw some of that in the presentation here, that if this is not constructed, then Railroad County will be able to service staff in the future, because everyone's going to take that. In time frames of sequencing, I didn't see that other than in the state of work, but so one is, did you factor that into how long that'll take, and then did you factor that into sequencing with first project that was presented in the railroad. And then overall, in delivering both projects, and then cost savings in that, time savings in that, and then something to present together in that fashion. I don't think that was part of the scope, but I think in some of these big projects, you know, they might get into a mega project here pretty soon, but these are some of the things that are out there now in project delivery.
I can answer the question about the construction stage in terms of timeline. Unfortunately, we do not have enough experience to necessarily gauge that. We were focused on terms of trying to make an efficient, what we thought would be the best chronological order in order to do the construction staging, and to what would probably be the least amount of cost and traffic impact within the area. We did not necessarily go into the time constraints because, again, we don't necessarily have that kind of experience. In reaching out, it was very difficult to find that kind of information. We had looked into those kind of things, but it was very difficult to find that kind of information, and thus we limited it in the end and focused more so on the process of itself, of how it was going to be constructed.
Okay. And the second question will probably go to the two project managers working together to see projects. So.
Right. I think we would, in the sequencing, I think we would want to try and build ours first, just so if that way railroad, if railroad was in construction, they could send all the traffic up to us. And then as you can see, our levels of service are B's and A's, so once the traffic goes up there, you know, it might go down maybe to a D and a C, but it's still above the F. But I think for both of us, for both of the projects, that's something we want to look more into on how to sequence both the projects, maybe at the same time, maybe we could find a way. I know we have more presentations that will focus on the combined presentation, so that might be something we could definitely look into. Yeah.
Just real quick, I don't want you guys to feel defeated. Hector's questions are absolutely, they're real life questions. You guys did great, okay? I mean, Hector just, when you set the bar, Hector's gonna push you to here. Okay, so please don't feel like you guys, I was like, man, Hector. but just take it as a compliment, I think, that, you know, he saw you at this level and he's ready to get you next level. Those are very, very different questions. Please don't get serious. I don't have any questions. I'm gonna be nice to you guys right now. You guys did a great job, man.
I don't know which one I need to say. I think maybe share your experience.
Okay, so my experience with the project, you know, I started off with a very busy schedule to begin the year with, without, you know, no one else going to be project manager. To be honest, initially, I took on the role as project manager because Gia asked me to, because he didn't know anyone in the group. So he came up to me and was like, hey, I'd like you to lead the project in the beginning. And I was like, okay, I'll do it. I'll do it for, you know, maybe the first quarter, and then I'll hand it off to someone else. See, because it's been a very, very busy year for me. But I guess once we got the ball rolling on the project, it just, I enjoyed it. I liked the project. I liked my team that I had, and I stuck with it. And you know, along the road, I definitely learned a lot in time management and knowing how to communicate with everyone. And I've kind of come to realize, like, you know, everyone's busy. You know, everyone's going to be, you know, super busy at a certain point, and you just have to learn how to manage, whether it be, you know, personal life, school, work. So I mean, this has been a great experience for me. It's helped me grow. It's helped me grow at my work now. You know, trying to manage that. And yeah, I mean, I wouldn't trade this experience for anything.
In the beginning of the year, we started off kind of with nothing, as mentioned before. It can seem really daunting, this project, and how we're going to do it, especially the two groups where we can communicate with each other and everything. I think this project has given me and a lot of us confidence in that we are able to create something out of nothing, in a sense. And that same fear is, you know, us going into industry, starting a new job. We don't really know as much as, you know, the people who've been there for so many years, but that we do have the skills and confidence to be able to produce work.
And as much as, me and Hector are the project managers, we're all, on the same level, we're on the same page, and kind of learning everything from day one. I just wanted to say that, I've learned so much from each and every one of these guys here, and I don't know, I'm really thankful for being in this group and for getting this much.
As for my experiences, I think the one thing that I really got out of this project was really just don't panic. Initially when I joined this project, I had very limited experiences going into anything related to transportation. And I was thrown into the traffic team, and I had very limited experience with Synchro itself. But with help with my group mates and just working with myself, I really got to learn how to use this program a lot more. And when I got thrown in, after that, I got thrown into construction staging. I had no idea what I was really doing. And so I just took it calmly and it was like, okay, what can I start with? So I started the baseline, and with help with like consultants and advisors and ideas from my group itself, I was able to learn a lot about construction staging. And so I think that's a really good lesson that I've learned to go into the real world, that you may not know everything, but you can always start at an initial point and learn from there, and you always improve with yourself from then on.
The reason I picked this project in the first place was I've had most of my internship experience in water, and coming close to graduation, I wasn't completely sure if that's exactly what I wanted to do, so I wanted to keep my options broad and get a look into everything. So I thought after talking to Dr. Chia and actually meeting Mr. Glassenwala at a conference, I'll give transportation another try in school. And naturally, coming into here, being in the water, I picked the environmental stuff so that I can help out with that. And APS came up at the end of the first quarter or the middle of the first quarter, and we none of us had an idea of what that even meant. And so I took on that as well. And after a couple of weeks of looking into it, we were just looking at examples online, and we didn't really have a lot of an idea of what it was. So what happened was I contacted someone at my internship who's a bridge designer, and then meeting with her every week, she kept on giving me feedback and telling me what I'm missing or what I'm doing, and helped me actually learn a little bit more about structures, and actually even environmental. I met with an environmental planner, me and Brandon from the railroad team, and we got her feedback as well. So it kind of gave us a look into what the professional environment is like, as well as our project being really in depth as well. And also just being around all these guys, the traffic team, just hearing them talk about it and seeing their presentations. I feel like I know more than most people in the traffic industry now know after hearing them talk about it so much. And so it was a really good pick, because I feel like it just taught you everything, and just researching, usually in your test you're given an example or a problem with you're given all the information. This, you're not really given anything. You have to research, go through thousands of pages of the highway design manual, and also just hearing all those abbreviations like SEQA and NEPA, and Caltrans has too many. It was really a good learning experience.
Yeah, I have to say the same. It was fun being around all these guys. As far as what I've learned, I've learned so much. I've learned a lot of the technical aspects, which I thought I had an idea about, but then you really come here and you figure out you barely knew anything. As far as traffic goes, I didn't have any idea what went into it, and I think I know exactly what their plan is and what they do, and you learn so much from everyone else. So it's not just about what you had to do in the project. You also just somehow had to learn everything else at the same time. So it was a really valuable experience for me.
At the beginning of the project, it was definitely overwhelming, but as a team, I think we took it step by step, and we got through it. And the teamwork experience that we had, the inner workings of the traffic team and the design team, the iterative process, I think it was a really valuable experience, and I really enjoyed it.
Auto turn. No, just kidding. That's just one thing. I think coming into this project, I didn't really, express too much of an interest in transportation. I think coming to the school, I wanted to do more water things, and then kind of transition over to geotech a little bit, and now I kind of have a sort of deeper appreciation for what goes on in transportation engineering. Aside from that, I learned a lot of things here. These guys they're all great guys, they're all helpful. So I was mainly a microstation type of guy for this project, and having to use Civil 3D was a little bit different for me, as I didn't have too much experience with it. But maybe in here, it's really helpful. Always help me out whenever I have any questions. And but I think one of the most important things I learned here is something intangible. It's how to work with a group that's this large. I mean, I've done group projects before, but it's always 3, maybe 4 people max. But having a group of 10 people total is just something completely new, and I think from what I've seen, it's also the way it actually works. You're generally working in large groups, and I think that was a pleasant experience.
Yeah, definitely. Building on what Teddy said, working in a group this large was a brand new experience for me, and being in a leadership role as the design lead was probably the biggest leadership role I've had. I think I've really grown from it, and all of these guys were great. Working with them was really easy, really helpful. And I think the best thing that I learned was my limits as a person. I remember there was a point in the quarter where we were trying to eliminate one of these alternatives to move forward with because we thought we could only handle 3. And Dr. Gia really wanted us to do 4. And I was like, you're crazy, we can't do this. But, we took on the challenge with a positive attitude, and we were able to complete it. And I was kind of shocked by the team and by myself, knowing how far I can go as a person. So, thank you, Dr. Gia, for pushing us hard. I'm really thankful for it now.
So before the project, I was kind of a hermit. When I came into class, no one really knew who I was. This project helped me to kind of open up, meet new people, talk to everyone, and it was a real honor to work with everyone from here. Traffic team from Railroad was great. We had our ups and downs. The moment I told them the roundabout worked, they're almost devastated. We had to redo the alignment.
We probably found that out, I would say, midway this quarter.
Yeah. I was like, guys, roundabouts.
And I got thrown onto the traffic.
It was a fun experience.
Yeah, it was a great experience for me too. I totally underestimated the scope of this project. I'll honestly say that I was only really aware of the geometric design process. I had no idea what an APS was, what ICE was, or any of that. So working on this project throughout the year, it's been a crazy ride. Going off of what Fabian said, adding the 4th alternative, I think we've all learned through other ways that even when you finish your work, there's always more work to be done. And it's just, this project has been a great experience, and I feel like it's giving more hands-on knowledge aside from just theoretical knowledge. Thank you, Dr.
Well, very good, gentlemen, very good.